everyone, welcome back to the YouTube channel. So today we'll be looking at another question from 9702 paper 22 May-June 2025. So this is a recent paper and we'll be focused on question 2, which is about moments. So without further ado, let's get into it. First question, 2A, define the moment of a force about a point. So as I've mentioned before, when it comes to definition, this is something that you should know before even you enter your exam hall, because it is free 1 mark. So of course you don't want to waste that free 1 mark, right? So anyways, the definition would be force multiplied by perpendicular distance of line of action of force from the point. In simple words, from the point means from the pivot lah. Yeah. So the key word in this definition is perpendicular. It is important to have the word perpendicular distance, because when it comes to moments in your calculation, you have to find the perpendicular distance, and you'll understand more when I explain question B. So let's go into question B now. A tree of mass 270 kg grows out of sloping ground and is supported by a post as shown in figure 2.1. 270 kg. Okay, this is your tree, and they give us some information. The ground applies a total force R on the tree at point Q. Okay. The center of gravity of the tree is a horizontal distance of 1.2 meter from Q. Alright. The post applies a force F of 1800 Newton. Okay. Which is this. It is perpendicular to the line PQ. Okay. The line of action of force passes through point P at an angle theta. Okay. To the vertical. P is a horizontal distance of 1.6 meter from Q. The tree is in equilibrium and all forces act on the tree in the same plane. Okay, so we have some information here. Let's look at Roman 1. By taking moments about point Q, show that theta is 25 degrees. So where's point Q? This is point Q. That means what they are trying to say is set point Q as your pivot. So if you set point Q as your pivot, ideally you don't have to include R in your calculation, because the line of action of force of R coincides with your pivot. Okay, now what are other forces we have? We have the weight. Weight is always at the center of gravity, and we have the F, 1800 Newton, which is this. So since they already said the tree is in equilibrium, therefore the sum of moment clockwise is equals to the sum of moment anti-clockwise. So this force of 1800 Newton is going to move anti-clockwise, while the weight is going to move clockwise. Okay, so you have the forces. Now the most important part is the distance. So you need to take the perpendicular distance. Alright, so let's look at the weight. What is the perpendicular distance from point Q? That would be 1.2 meters. Right, this is perpendicular to each other. So we have that. Now let's look at 1800 Newton. What would be your perpendicular force? So your perpendicular force ideally is supposed to be this. Right. So to find that, we can use this value, 1.6 meter. So if this is 1.6 meter, this has to be 1.6 meter as well. Right. So if I draw a line here, we have a 90-degree triangle here. And this would, if this is theta here, this would be 90 minus theta. Right, okay, let me draw the triangle at the side here so it's clearer to see. This is 90-degree angle, 1.6 meters. So initially your triangle looks something like this. Okay, wait. Okay. Initially your triangle looks something like this. So this was your theta, and if you realize this is actually a 90 degrees, right? Then this has to be 90 minus theta, right? And you're going to find this length, which is x. So what can we do? We have, this is hypotenuse, this is opposite. So that means you're going to use sine 90 minus theta equals to opposite, which is 1.6 divided by the hypotenuse, which is x. And therefore your x would be 1.6 over sine 90 minus theta. So in maths, sine 90 minus theta has another meaning, which is 1.6 over cos theta. Sine 90 minus theta is equivalent to cos theta. If you want to leave it as sine 90 minus theta, is also no problem. You're still going to get the answer. But if you want to save a few seconds of your working, you just straight away write cos theta. Both is going to give you the same answer. It depends on your perspective. Okay, so we've got the distance. Now we can calculate it. So sum of moment anti-clockwise is equal to sum of moment clockwise. So anti-clockwise we have 1800 Newton. The distance will be 1.6 divided by cos theta equals to clockwise will be your weight, and your weight is, they give you the mass of the tree is 270. Don't forget to times 9.81, yeah, because this is just the mass. Your weight is equals to mg. Don't forget, it's a very common mistake to forget 9.81. Yeah, and multiplied by your perpendicular distance, which is 1.2. And let's calculate. Okay, make sure your calculator is in degrees because they want it in degrees. If it's not, you're not going to get the answer. So this is 3178.44. Cos theta would be 0.906104.9. I have a habit of writing more decimal place in between my calculation to ensure accuracy. Yeah. And you'll get 25 degrees shown. And this would be your answer. Yeah. So actually, there is another way to do this question. But that way is not the right way to do it. But I know some of you might be thinking of that way because I thought of that way as well. So let's look at that way so that you don't do this mistake. Okay, I'm going to erase this whole thing. Okay, I'm going to erase this whole thing here. Okay. Now, okay, we saw the weight just now. The weight remains the same. The weight, and you have your perpendicular distance 1.2. So the weight is not an issue. Now, the issue is this particular force of 1800 Newton. So, remember I said the force has to be multiplied by the perpendicular distance, right? So now what would be your distance? Just now we take the distance as this particular distance. We did a triangle, we use Pythagoras theorem, and we take this particular distance. Okay, so now you might be thinking, what if, right, I resolve the force, okay, that means I take F cos theta, okay, I resolve the force, and I multiply it by 1.6 meter. Is that possible? So here's the thing, you will not get the answer. You will not get 25 degrees. In fact, you will get cos theta as more than 1, which is ideally, you will not be able to get any angle. So why is that so? Because based on this diagram, right, your force is already initially perpendicular to your axis. This is your axis. Wait, let me take a color. This black color line is your axis. Axis is a line where all your force is acting. See, your weight is also acting here. Your R is also acting at this line, at this axis, and your force is also acting this axis. So, initially, your force is already perpendicular to your axis. And when your force is already perpendicular to your axis, you shouldn't resolve it further. You must find a way to find a distance that is perpendicular to this force, which is what we did just now by finding the x. Let me give you another example to it. So, let's say if you have, this is your axis, or basically your distance x, this is your pivot. Then you have a force here. So, this is your x. Okay. So your force here is not perpendicular to x, right? So ideally what you're going to do, you're going to resolve it. This is theta. You're going to resolve, and this is f cos theta. Right? It's perpendicular. So you get f cos theta. Another way to look at this is, you have x here also. Your force is still the same, the force. Still, it's not perpendicular. So instead, what you're going to try to do now here is, you want to take x cos theta instead. So, this two-way will yield you the same answer, because when you find your moments, you see moments for here, it's going to give you f cos theta multiplied by x, perpendicular distance. Here is also f multiplied by x cos theta, which is, both are the same thing. F multiplied by the perpendicular distance. So if you realize, in this case, both cases, your forces are not perpendicular to the line of axis. Your axis, which is your axis here? This is your axis, okay? Because that is where your force is acting. So the axis is the line where all your forces are acting. So it is not perpendicular to x. You see the f here, it is not perpendicular to x. Same goes to here. It is not, it's like a bit slanted, it's not perpendicular to x. So when your force is not perpendicular to x, you have a choice to either resolve your forces, like the first case, or you resolve your length, like in the second case here. You have a choice, because your force is not perpendicular to the axis. Okay, in this case, let me erase this. This is your axis, and the given force is already perpendicular to the axis. So you shouldn't resolve it further. You should find a way to see which length is perpendicular to the force. So let me repeat again. When the force is already perpendicular to the axis, you shouldn't resolve your force further. That means you shouldn't find a way to get f cos theta and multiply by 1.6 meter. You will not get an answer. You must find a way to get the perpendicular distance instead. But if in these two cases, your forces is not perpendicular to your axis, then you can choose to either resolve your force or resolve your length. So that is something to be aware of. A different way to look at it is, you go back to your main definition. They said here, the force is multiplied by the perpendicular distance of line of action of force from the point. That is the definition of moment. Realize they did not write perpendicular force, they wrote perpendicular distance. That means, in other words, what they're trying to say is, you need to make sure your distance is the one that's perpendicular to your force. That means you must find your perpendicular distance. No matter how your force is, you must find a way to make the distance perpendicular to your force. Because they said perpendicular distance. That is another way to look at it. But of course, the simplest way is, if the force is perpendicular to your axis, find a way to make your distance perpendicular to it. Don't resolve your force. You will not get the same answer. But if it's not perpendicular, like in these two cases of scenario, you can resolve either one, you get your answer. Yeah. So just this is something to be aware of. Because when I first did this question, my first method was, I resolved the force as F cos theta. Then I realized, I'm not getting the answer. In fact, I got cos theta more than 1. And I realized the given force is already perpendicular to the axis itself. So I shouldn't be able to resolve it further. So that is something you should be aware of, because it's going to give you a very different answer. In this case, you might realize, because they ask you to show theta is 25 degrees. If they didn't ask you to show, they ask you to find, and you might be a bit stuck because you will not get the answer. Yeah. So one more time, your axis is the line where all your forces is acting on. Okay, now let's move on to Roman 2. On figure 2.2, draw a labeled scale vector triangle to represent the forces acting on the tree. The weight of the tree has been drawn to scale. Okay, now this is where you have to be really, really careful. You cannot simply draw, because they already said that the weight of the tree has been drawn to scale. That means you must follow the scale given. So, your weight is 270 multiplied by 9.81, and that was 2648.7, right? So what you have to do is, you go and take your ruler, and you measure this length. What is this length of the weight given? And when you measure it, you ideally should get around 3.4 cm lah, plus minus around that 3.4 cm. Not 3.4 cm, 13.4 cm. Why did I say 3.4 cm? 13.4 cm. So if 2648.7 Newton gives you 13.4 cm, then you have a force here, right? 1800 Newton. So for you to draw the triangle, you must find how many cm is it for 1800 Newton. And when you do your math, you should get 9.1 cm. But just in case, I will check. Yep. Yeah, you will get 9.1 cm. Yes. So, this is for F. For R, you don't know, because the forces that you have to draw here, right? Okay, let me draw first, because I think I should have shown this first. Okay, you should draw your weight, your force F 1800 Newton, as well as your reaction force. Not reaction force, they did not say it's a reaction force, they just say it's a total force of R. Yeah, you don't know how much force is R, but you do know what is the value of your weight and your F. So with these two information, you can draw your R. Okay. So first of all, you must know what is your weight. Then you measure your weight. Measure this particular line using your ruler. Okay, so make sure you bring a ruler in your exam hall. Okay, 13.4 cm. Then what you do now is you're going to draw your F. So this I'm drawing on a tab, so it may not be as accurate, but make sure you measure 9.1 cm on your ruler and you draw it. Okay, accuracy is really, really important here. So should be somewhere. Okay, this may be too long. That may be too long. Okay, approximately, right, I think it's, yeah, okay, something like that. 9.1 cm. Make sure you use your ruler. Don't freehand. Yeah, I freehand because I don't have a ruler here. Yeah, so 9.1 cm. And this should be 25 degrees. Right? Because you have already found your angle here 25 degrees. Might as well just put your angle here 25 degrees. Okay. And this is your F. So I'm just going to label here F 1800 Newton. Okay. Now is when you draw your R. So how do I know I have to draw my F this way and my arrow is going to point this direction? Why? Because in the diagram, your F is pointed in this direction. So you just follow. Then your R is pointed in this direction. Therefore, you connect these two lines and this would be your R. When you measure this R, you should get around 6.1 or 6.3 cm. Around there, like approximately plus minus around there. If you draw this and this accurately, your R will confirm be accurate. That is why I say, use your ruler. Don't be lazy, okay? Use your ruler. Okay, just measure it. 2 marks, you got it. So whenever they say drawn to scale, draw it to scale, follow the scale given. Okay, so make sure you label at 25 degrees and your forces. You want to label 9.1 cm, sure, no problem. But this one, make sure you put one value. Let's say you measure and you got like what, 6.1 cm. Just write 6.1 cm. That's it. Don't write 6.1 to 6.3. You don't give the examiner choice, okay? I am giving you the range because it can fall between there. So if it's 6.1, just write 6.1 cm and label your R. It's a closed triangle because it's an equilibrium, lah. Yeah. Okay, so you got your 2 marks. That's it. So accuracy is really important here, yeah? Okay. Now, we have done with Roman 2. Let's move on to Roman 3. I think Roman 3 is the easiest out of these two. Yeah. The tree exerts a pressure of 150 kilopascal on the top of the post. Determine the surface area of the tree in contact with the post. So this is a bit of mixture of pressure. So you know pressure equals to force per unit area. Your pressure is 150 times 10 to the power of 3. Why? Because it's in kilopascal. Don't forget to change it to pascal. Equals to force is 1800. Why? That is the force acting on the post. Right? And every force has a reaction force. And here they ask what? 3 exerts a pressure of 150 kilopascal on the top of the post. Determine the surface area of the tree in contact with the post. So they are telling that tree exerts a pressure. So that means the tree is also exerting a force. So if there is a force acting on the tree 1800 Newton, there will be a reaction force equal and opposite 1800 Newton as well. So that's why it's 1800 Newton divided by your area. And you should get your area S. Let's calculate. You should get 0.012 meters square. And you got your 2 marks. Okay, so that's about it. 3 questions, 2 about moments. So 1 about moment, the other is testing your accuracy and drawing of vector triangle. And last one is a bit on pressure. So a few things to be aware of. I'm just going to revise through one more time. Make sure your forces, okay, is something that you have to be very careful of. If your forces is already perpendicular to your axis, you need to find a distance that is perpendicular to the force, not resolve the force. If it's these 2 cases where the force is not perpendicular to the axis, you can resolve either one. Whatever is it, fall back to your definition. Definition, they say perpendicular distance. So ideally, no matter how your force is, try to find a way to find the perpendicular distance to the force. Most important thing, okay, in simple words, if your force is perpendicular to your axis already, don't try to resolve it already. Find a way to make the distance perpendicular to the force. Okay. What is axis again? Axis is a place, is a axis, or you can say a line where all the forces is acting. Okay. Then this part, they already said has been drawn to scale, so you must draw it to scale. Find what's your weight, then measure this length, do your maths, you'll get 9.1 cm, draw your force, label your angle because you already found your angle here, then if you accurately measure your weight and your force, somewhere around there, you should accurately get your R force as well. So maybe you get 13.5 cm or 13.2 cm, plus minus is around there, doesn't matter, because Cambridge usually take plus minus a bit of the value lah. So as long as you see your value properly in your ruler, you are good to go lah. Because I'm not using ruler here, so I just have to like roughly draw it lah. But you're doing it on paper, make sure you get it accurately. Okay. Last one is just finding your area. Make sure, as usual, always write your formula first, because even though you accidentally made some mistake along your calculation, you'll get 1 mark for your formula, and you don't want to lose that mark, right? Yeah. So there you go, your 8 marks, and that's all for today's video. I hope you gain a better understanding on how to calculate moments and of course draw a vector triangle. And that's all for it. Thank you for watching, and I'll see you in the next one. Bye bye. Remember to drink water, okay, and stay hydrated. I'll see you in the next one.